All right, hey guys. I just want to go over this quiz with you really quick and kind of show you how to do these problems. So the first one we have, sorry, it's highlighted, is state the domain of. Now mine are going to be kind of in a different order than yours, right? Because they scrambled the questions. Sorry. My brain's a little bit fried. They scramble the questions. So, domain of the inverse tangent function. So remember tangent inverse, right? If I look at tangent inverse, so I had quite a few people. When they told me the answer, they said that that answer was that negative pi over 2 to pi over 2. But remember, that's the range of it. That's where tangent inverse, remember, this spits out some angle theta, right? So if you think about tangent of theta equals some number like y or x or something, that tangent actually can spit out any number it wants, right? And of course we can put in any number we want, but we restrict it so that this thing is a function. Okay, so when it's asking, remember this is the domain of the function and the range of the inverse. Remember that those switch, right? When we take the inverse tangent. So what can I put in to tangent inverse? I can put in anything I want. And what is it going to spit out? It's going to spit out an angle and quadrant between negative pi over 2 and pi over 2. So what is our answer there for that first one? I don't know why I put 0 to pi. It shouldn't have been. Our answer is going to be that negative infinity to infinity. Everyone's invited for to tangents party. Okay, so the next question was the cosecant inverse. So I had some questions about this one. So this was number 2. It may have been number 2 on your quiz. It may have been number 10 on your quiz. But cosecant inverse of a negative 2. So remember, these inverse trig functions spit out angles. So whenever I'm in doubt, I would set it equal to an angle, and then hopefully I can figure out what's happening, right? So I'm gonna set it to an angle. What do I know cosecant? So anyway, so this, what does this mean? This means that there is an angle, right? That when I take the cosecant of it, it gives me negative 2. So another way to say that is that the cosecant of theta equals negative 2. Okay, so what is cosecant? Cosecant is 1 over sine of theta. Okay, so be a little careful here. I had several of you that made a mistake here where you put it as 1 over sine inverse. It's actually not. So if you look at this, if I flip both sides of this equation right here, right, look at what we get. We get that the sine of theta equals a negative 1/2. And so if I wanted to rewrite that, then I need an angle theta that is equal to sine inverse of a negative 1/2, right? That's actually what that equation is saying. So notice what flips. The thing that flips is that negative 2. It is actually not the function itself once I rewrite it in terms of sine. All right, so now what do I need? I need an angle theta, right? That, now where does sine inverse spit out angles? Sine inverse spit out angles in 1 or in 4. Now I know I say 4, but remember that's negative pi over 2 to pi over 2. So again, we really want to make sure we think of this down here as a negative pi over 2 and this up here as pi over 2. So what is my reference angle going to be? Well, I know when I take the sine of 30 degrees, right? That's 1/2. Now I believe we need to be in radians. We do. So 30 degrees is pi over 6. And you guys, you have your notes, right? You should be using your chart. Use your chart. Write down the relationships between radians and degrees, right? Pi over 6 is equal to 30 degrees. Pi over 3 is equal to 60 degrees. You use those resources because now you have them. You wouldn't have had them before. Now you have them. Okay, so look at what I have then. I know it's, but pi over 6 gives me a positive 1/2, but I want a negative 1/2, right? So I actually want that angle to be in the 4th quadrant. And how do we drop that down into the 4th quadrant? We just put a negative on it. The reason that I don't want to put 330 degrees, right? I know those are coterminal angles, but that 330 degrees does not lay between? Who cares? Negative pi over 2 and pi over 2, right? So what's my answer here? It's going to be that negative pi over 6. Okay, let's look at the next one. Okay, I think a lot of you got this one or one similar to this one, right? So tangent inverse of the square root of 3. So tangent inverse I know is going to also spit out angles in 1 and 4, except it can't grab the y-axis, right? So 1 or 4. Tangent inverse, what angle when I take the tangent of it gives me root 3? Well, I know that I know that this is sine over cosine, right? This is just how I kind of think of it. But if I had my chart, I would just look at my chart, yeah? So I know that this must be root 3 over 2 all over 1/2. Yeah, and what angle when I take the sine of it gives me root 3 over 2? That would be, again, 60 degrees, right? Because I just saw that 30 degrees gave me 1/2. So I know that my angle then is 60 degrees, which is the same thing as pi over 3. Now, do I want the positive or the negative? I want the positive, right? Because pi square root of 3 is positive. So my answer here is just going to be pi over 3. Okay, that one. Might as well get that one right. All right, cosine inverse of 0. Hopefully that was a pretty easy one, right? What angle? Well, I'll try and move that, but it might not be working. Well, what angle when we take the, oh, there we go. Cosine of it gives me 0. Well, cosine, remember, are your x values, right? So where is cosine x? It'd be, nope, where is x 0? If I'm hanging out on the y-axis, right? So cosine inverse of 0, not of theta. Oh my goodness. Remember, cosine spits out angles in the first and second quadrant. So I know I don't want 3 pi over 2. I want pi over 2. Okay, cool. Next one. Let's do this. All right, this one. So I had saw quite a few mistakes on this one. All right, here's the thing. Wouldn't it be nice in life, and wouldn't it be nice to have easy things in life at this moment in life anyway? Sine inverse. So I had many of you cancel those two and tell me that this answer is 5 pi over 4. That's absolutely wrong. Here's the reason it's wrong. 5 pi over 4, right, is going to be in the third quadrant. I know sine inverse will never, ever spit out an angle that is in the third quadrant. Where does sine inverse spit out angles? It spits out angles, right, in only the first or the second quadrant. So it doesn't make sense that this would equal 5 pi over 4. So that's not the answer. Okay, so let's think about this a little bit more. Let's take our time and not just assume things. We know what assuming does. Let's work our way in. Let's work our way from the inside out. So sine of 5 pi over 4, right? Sine of 5 pi over 4. Whoa, I don't know what my pen is doing here. As we just saw, 5 pi over 4, right, is in the third quadrant. It's pi over 4 away from pi. Oh, am I writing outside of? Oh, I almost am. Third quadrant, my reference angle is pi over 4. So sine of 5 pi over 4 is going to be a negative root 2 over 2, right? Or negative 1 over root 2. Okay, so what do we get here then? We get sine inverse of a negative root 2 over 2. So see how I'm breaking this problem down into its parts? So now I can look at this and I can say, okay, now I'm taking the sine inverse of a negative root 2 over 2. I know sine inverse spits out angles in the first and the fourth quadrant, right? Or between negative pi over 2 and pi over 2. I know my reference angle must be pi over 4. That's what I just got. I know it's negative. Yeah, and so what am I going to be? I'm going to be in an angle in the fourth quadrant here. How do I push that down into the fourth quadrant? I just make that negative. Okay, so please be careful. The inverse functions don't always undo each other because we've restricted the domains. Okay. All right, I know I'm kind of slow at this. Secant of a negative 2, we're going to do the same thing that we did with that cosecant of a negative 2, right? So secant of negative 2. Secant inverse, excuse me, of negative 2, that's going to be the same thing as cosine inverse of a negative 1/2, right? So go back, if that doesn't make sense, rewind this video and rewatch that little part where I talked about the cosecant. Where is cosine inverse spit out angles? It spits out angles in quadrants 1 and quadrant 2, okay? When is cosine of what angle would give me just a positive 1/2? Well, I know sine of 30 is 1/2, so it must be cosine of 60. And what is 60 in radians? It's pi over 3, right? That should be stuff that is easily accessible to you when you're taking your quiz and your test this week. All right, so I know my reference angle is pi over 3. I'm not going to make the answer a negative pi over 3. Guys, that'd put you in quadrant 4. And cosine inverse never ever would be seen in quadrant 4, right? So what do we want? We want this angle right here. That's in quadrant 2 because that's where cosine is negative with reference angle pi over 3. So we are a pi over 3 away from pi, so that means we are not quite to 3 pi over 3, so we must be at 2 pi over 3. Okay? All right, I hope that makes sense. Halfway through. Let's keep going. So this next one also very, very similar to the one we just did. Are they going to undo each other? Well, this is the cosine inverse of the cosine of a negative 5 pi over 6. Is this just going to equal negative 5 pi over 6? Where is a negative 5 pi over 6? It's right here. Cosine inverse wouldn't be caught dead in quadrant 3, people. No way. Cosine inverse will only be in quadrants 1 and 2. So we have to work our way, right? So what is the cosine of a negative pi over 6? Negative 5 pi over 6. Well, the reference angle is pi over 6. Cosine of pi over 6, I know. Well, it can't be 1/2 because I just said that cosine of pi over 3 was 1/2. So cosine of pi over 6 must be root 3 over 2. Because we're in quadrant 3, it must be negative. Right? All right, so what do we have? Whoa. I have now the cosine inverse of a negative root 3 over 2. Okay, so now how would I do that? Okay, so where does cosine inverse spit out angles? Cosine inverse spits out angles in 1 and 2. Because of this negative right here, I know that this angle is going to be in quadrant 2. I also know from the work that I just did that its reference angle is going to be pi over 6. So if I'm pi over 6 away from pi, that means I'm at 5 pi over 6. Okay, so that's my answer for that one. Good. All right, domain of inverse sine, right? Inverse sine of x. We're going to spit out some angles. This would be my range. The range of that is negative pi over 2 to pi over 2. We talk about that a lot, right? Because when we're solving these problems, we want to talk about that. But what kind of inputs can I put in? Just negative 1 to 1, right? Think of sine. The graph of sine looks a little something like this. That's a horrible, horrible graph. What is the range of sine? Negative 1 to 1, you guys. So if the range of sine is negative 1 to 1, that's going to be the domain of my inverse. Remember all the wonderful times we had in Math 1400? I know you had a wonderful time in that class because I taught it to you. Or maybe I have a wonderful time in my head and you guys don't have a wonderful time. But remember, we're talking about domain, so it's negative 1 to 1. This one should be pretty easy, right? Sine inverse. Come on. Oh, wow. That's kind of trippy. Of root 2 over 2. Sine inverse is going to spit out angles in the first and the fourth. I know my reference angle here, right, is going to be pi over 4. Because I know that's when I take the sine of it, I get root 2 over 2. And it's positive, so this is pretty straightforward. That's just going to be pi over 4. Okay. Oh, which they actually want radians this time, or excuse me, degrees this time. That's 45 degrees. I think I'm going to get a really bad score on this because I haven't entered like half of the problems here. And my problems seem to get easier as I go on. I don't know if you guys found that. This one also, same thing, root 3 over 3. Tangent inverse of root 3 over 3. Where does tangent spit out angles? 1 and 4. Well, this is the same thing as tangent inverse of 1 over root 3, right? So I think I have 30 degrees, right? And we want degrees and radians. So that'd be pi over 6. It's positive, so I'm going to keep it in, wow. Wow, settle down there. I'm going to keep it positive, keep it in the first quadrant here. So that's 30 degrees or pi over 6. Yeah, cool, good. 2 more, come on, let's do this. Okay, this one, I had several people ask me questions about this one. This one is a tricky one. And those of you that got it, nice job. All right, so let's go back to what I've been talking about before. So cosecant inverse of a negative 2.0483. Okay, if you have a calculator, do this one with me. Remember, this gives me some angle theta. I'm going to go over this description again. So that means that a negative 2.0483 is equal to the cosecant of theta. That's the same thing. Okay, so a negative 2.0483 is equal to 1 over the sine of theta. Yeah? Okay, now flip both sides. And I'm going to just move it to the left because I like it over there better. So I'm going to flip both sides. So I'm going to get sine of theta is equal to 1 over a negative 2.0483. Okay, so what does that say? So what is theta? Then theta is equal to the sine inverse of 1 over negative 2.0483. See how you can take, guys, mathematics is just the purest form of, well, I want to say science, it is, but the purest, form of logic, right? So if you can, I hope that you get to where you're not just following a bunch of patterns and not really understanding what's happening, that you're actually thinking about what does it mean? What does it mean to take the cosecant inverse of something, inverse cosecant of something? I know it's going to spit out an angle, right? How is this angle related to sine? So now I can put my calculator, see what mode I'm in. I'm in radians right now. So now I can do inverse sine of 1 divided by a negative 2.0483. Not 1 over inverse sine, but sine inverse of a negative 1 over a negative, right? So this would equal, I got a negative 0.510037. But it's asking me to round to 4 decimal places, 1, 2, 3, 4. So I'd have a negative 0.5100. That's in radians. I can multiply by 180 over pi, or I could just redo this again by putting my calculator now into degrees. Press second answer. Second answer. Whoa. Press second answer. No, not second entry. Jeez, Sarah. And this is 29.22298. Now, if I round this, let's talk about rounding. 1, 2, 3, 4. That 8 is going to round the 9 up to 9.22. That in turn is going to go to a 10, which will round that 2 to a 330. Okay, so there are my 2 solutions for that problem. I hope that makes sense. If that didn't make sense, then please holler at me and let me know if it didn't make sense. Because guess what, you guys? You're seeing this on Thursday. You're going to see similar problems on Thursday. So if this isn't making sense now, then you gotta I don't know if I'm able to get rid of that circle thing there. That's all right. I kind of like it. Oh, there we go. Okay. Last one. What do I got? I got tangent. You guys did a good job on this one. I thought this one was kind of hard. So we have tangent of cosine inverse of a negative root 3 over 2. I guess you could have just plugged this in your calculator, but I like to think you didn't do that. I like to live in this fantasy world where you do math because you like it. So cosine spits out angles in 1 and 2, right? What angle, when I take the cosine of it, gives me root 3 over 2? Well, that reference angle must be 30 degrees because I know that. So this is going to be 30 degrees. Let's just say in degrees. Why not? This is going to be 30 degrees. So what is my angle actually going to be? What is this all going to be? Whoops, sorry. It is going to be 150 degrees, right? Okay, so look at what this is saying. This is the tangent of, all that stuff inside was 150 degrees, right? The reference angle is 30 degrees. So really, and tangent in quadrant 2 is negative. So this is a negative of what? Run over root 3, correct? 30 degrees. And if the computer took off for not rationalizing the denominator, but you got that correct answer, I gave you full credit for it. Okay, you guys, I hope that helped. I'm still going through your work. I'm going through all your written work, and then I have your quiz up at the same time, and I'm awarding partial credit as I go through there. So look at my notes, look at the attached document if that makes sense for your work, and let me know if you have any questions.